Hello, welcome to another video. So what we're working on is I just kind of run that. I don't know, that was probably quite loud. We're working on a tool that basically is emulating a virtual terminal from the VT500 series. So there's this state machine that I've kind of implemented part of, and we're at a point where we're kind of working on making it colorful, I guess, for a better sense of the words. So I'm implementing the SDR CSI code, which is what we can do is go here and we can basically let the editor tell us. Let's just bump this. Does that not work? That works. Cool. So yeah, select graphic rendition. That's what it stands for. So what we're doing is basically, and there was a bug in the last one, which I last video. I might just briefly talk about that. So at the moment, what we're doing is we've got a system of things where we have some attributes that are defined like a bunch of macro functions that you then have to kind of define where you want to use them. So here we've got, this is what happens on the C, so we use case here. And that way we can see just print out here, which I've kind of added recently, which is, it just prints out here. So we can kind of see in the editor where things are happening, like where printouts kind of get happened. Now, this one is potentially a good place to talk about this. So if we look at set append, well, really array append, which is up here, but really array ensure capacity, which is up here. So there was a bug here, and the bug was I did not have so I didn't have brackets around that, well, really around this one here, and putting brackets around fixes it, and I should probably put brackets around here actually, which I can do with that. Oh no, that was way too much. Oh yeah, I see what I did. I'm not sure what that did. I want that, yeah. So what was happening was in here, the cap was actually just whatever comes in here as a direct replacement, texture replacement. That's how macros work. And as I'm explaining this, I may as well get rid of that here statement so I don't do it. And you'll notice that the here wasn't actually where it was. I had to do a couple of jumps because you're in a macro, and that's how the file macro gets, well, the line macro extends to the position where the first macro expansion was, and then when you further expand, it's the same place in the code where it actually is. It's kind of, that's how it works. But you might be thinking, why do you need that? Some of you will know, and perhaps I should do the same there. Like so. And perhaps also there, though, that's less needed. Anywhere else. So the reason why is because this array ensure capacity is actually called from array append, and we get array assure capacity, and we pass in this parameter here. So we actually, this text got put up into here, and so instead of cap times size, like capacity times size, what you would think, what was actually happening was current size 0 plus 1 1 times size, which was 4 in this case. So we'll allocate 4 bytes. So that was all right for the first case. The second case, it got like 2 times 4 is 5. That's now 8, which is what it should be. But what it was this was now 1. We add 1 to it. But that's not really what was happening. It was we had 1 plus 1 times size. So we had 1 plus 4, which is 5. So it was, that worked. The math worked out, but just the way the programming language does it, it's just how it happened. And I think the rest is all right for stuff. Potentially we should, we do it up there, but yes, we should do it there because you can, let me think there for a second. Can do that. Now I might just jump back to where I was because continue talking through this. So basically we printed out, this is the code we got, so we can kind of see which code it is, and that kind of prints out what the name is, and we define what the name is at the top, just so we can see kind of what the program is expecting, and then we can compare. So I might leave that in for now, but this realloc one will kind of disappear, which is all good with me. Now this one, this is, we are just kind of printing out all the attributes. So this is kind of how I kind of did it. So we've got a set for each. I guess I could show that it's actually an array for each. It's new since last time, hence the pluses in the gutter. All it does is it takes an array and some code and does that, and then kind of sets a variable called element in this and IDX. So now in this kind of scoping environment, you have IDX and element. I actually go into another scoping environment, which potentially in this environment I should shadow the IDX, like do kind of size t IDX equals IDX. I think you can do something like that and then do that. I think I might do that because I think that means in this code, whatever it does, it can't actually modify IDX. So it will literally do it for each element, even if you kind of change it. But perhaps like part of the for each deleting thing, I don't know. But yeah, so in this case, what we were doing was kind of saying what it was. So here we have this attribute and this attribute. So we can kind of see, was that the correct thing? We get bold and we get green to 2. And we can compare that to, I think, here. And down here it tells us, yes, green is the second one. And we can also see that this was foreground green. We could potentially in this one print what the parameter was. Param, and this is just a one over that, and we can in here then pass in this. It's kind of weird that the name's there, but the name is a string, which perhaps I could do this a little different just to make it clear, but VT isn't a good one. VT program, that one. VT E and here. So something like that. And what we could do is do a %s, and it's like slightly extra thing, but it perhaps reads slightly better that you're doing that, but then maybe you're wondering what the name is. It's the one all the way over there. But anyhow, I'm perhaps just painting a black shed. All the colours in the world. So if I just go out there, we can kind of see what that kind of changed. So this isn't what I want. IDX is not kind of what it. Yeah, so that shadowing. Can you not shadow in? So I think at this point it's allocated this in the scope, and then it's setting it to itself, which is a random value. It could be anything. It just happens to be what is on the stack at that point is that. So I can't do that, but I can have this. Cool. So now this is kind of showing through all the things that we have, and these perhaps aren't actually as useful. I thought this would have had another statement of interest. Yeah, I thought there would be a bit more. Because I thought in go to print and we go to we print this, that would get us to where we want to get. Be real slow. So in this, yes, we do a set copy. Perhaps I did want to I've taken it out. This is the best way to do it. I perhaps do actually want this. So that. I think I do want to keep in this, and that can be P, and then this can be U. And then we can pass in that and pass in that. And there we go. And that's all right. I can fix that. We can just call it avoid star. Well, I suppose I turn on all the warnings in particular, but we can have this and kind of close that. Here we can kind of see what is happening, and we can see there is actually quite a few relics. We give that a bit more space. And the relics are happening in this set copy. So I've actually put in a little thing, maybe doing a copy on write type thing. Perhaps I'll do that this time. Maybe I'll do it next time. I just thought I'd mention that it is something of note. But yeah. Right, so this now got some things we had. That would have just been bashed at a different thing, but it's not doing the. So in this, surely it would have some stuff, so it does a gutter. Perhaps that gutter could be a separate thing. So we have this. This and it never happens. So kind of what I want to do is do that same thing, but maybe pull it in here. That's printing in a lot, isn't it? I think the hairs we are also printing to stand it out, which perhaps I don't want to do. And the unimportant, the unreachable, perhaps I will. So if we do that, it's at least busy. We're gonna reopen that. Did nothing come through on that? Whether that changed? All right, so you have to have all that coming out on the standard out. Why not read standard out? I could change the script to do so, I guess. Yeah, so yeah. I want to kind of see a case where um, like these are different. And I would expect so I did make that change before, but then I think I want to do want to do something like or and do that one. Do something like that. Yeah. Cool. That's taking me somewhere I don't know. So I think I momentarily don't want to do this. So what we can do is just do that. And it's kind of like a no up. I don't know why it's not displaying, but I potentially do know why. What we can do is have a look through here. So at this point here, yeah, so now we're getting this unimpull. Yeah, that's kind of what I wanted before. And perhaps now we can kind of just call this here, just to kind of say that perhaps we could say to do. Reason why is the unimpull either aborts or returns. Here does not, here will continue. And that is why we didn't kind of get any output, but now we get some output and you can kind of see the bash prompt appears down the bottom. Perhaps if we, no, that just makes it worse. But if we type kind of normally, it does some things, but there's some printing, which I think I can kind of fix. If so I'm kind of running everything through this here, and yeah, I could perhaps do something like that, and then the yeah, do that. Take me there, and then take me there, then take me there. I think this means ooh, we can kind of get rid of and keep that one and just all of these. So undo that. We can just have a display that kind of just works, and there's no random stuff that comes out, but there is stuff that comes out here. that looked like an extant error as well. We're doing some leaks. That's all right. We have a unimplemented for clearing stuff, but as long as it's not other stuff. And now we kind of still get all these hairs. That's actually quite good, and it kind of prints out the other bits of that as well, so that can be kind of useful. So if we get down to it should be some point we print all this. Yeah, so this is kind of where we're printing. So we're in the middle of draw screen, and I think what I might do is maybe make this like a tad smaller. I kind of want to put this gutter into a separate function. So what we can do is maybe yoink that and put the draw gutters, and we can do a TVP, then that'll kind of draw the right, so yank that and redo that and then paste that and then there do this sort of thing. You know what? Cool. And then here, after we do this clear screen, we can do a VT gutters and let's do that. And so it should, right, so it complains about that. We can yoink this, go to, perhaps I can yoink that, go to there and do that, and so just yoink that one up. So it mounts to be a little, and then I can get that there, and perhaps also the clear screen. And then we get some things. Cool. We can type numbers and we get output. We get a bunch of stuff. We get dumped down to here. Cool. So we want to find we're kind of printing. So what we're doing here is at this point here we might have printed out some arbitrary data onto the screen, but we may also be right at the top. But at this point, we also know that whatever the last attribute is, which is up here, is not what we currently have. Oh, I wonder if that's a better way of... Yeah, because... Yeah, I think... we can have that, and I want this to be a pointer to a thing, and we can have it just pointing to unique to start with. It's gonna screw up the copy and write stuff, but we can kind of make a note. Note. Right. We should just do that. Don't even have it implemented yet, but it might break it. Right, but so in this case here, At the end of this branch, what we're going to have is the last attribute equals the pointer to this cell's attribute. Just trying to think of how to reduce memory consumption, and having pointers to things can sometimes help. So it will probably contain a few things. Oh, we can't do that, can we? That just means that we need to kind of define one of these things. So perhaps where do we do it there? Where do we define the sets and whatnot here? So what we can do is we can type def set of VT attribute, was it? And we can type def that to VT attribute set, and that can be the thing we were. And then here we can have this as a like so, and I'll do that, and do that. Everything else should kind of work. No, I kind of want to find all the set of VT. Yeah, take me to there, because there is other places, and we can do something like that, and do something like that, and that can be the two places. Cool. So this is a weird way of telling me that the one of these I need to dereference first. And does that kind of work? This we can dereference like that. And cool. So that's that. We're kind of not making any change, but I might see, is that kind of what we can do? What about we don't do that? I want to just stay here if possible, but I also want that other information to get printed. Hard decisions. Right, so in this point here, what I kind of want to do is kind of do some more define stuff. So what I'll do is do that and that. What we can do is close that for now. And so where we have attributes, we have this like so. So we kind of need to define a few things like that. Now, what I want to define is I don't really care about name. The code I kind of do care about, but not like that. I care about this code more as the case. And this code is like the CSI code. It's not really the best use for both of these, I guess, if we're going to use both. So perhaps I'll just do that. Yeah. We can call this the code, and this can be the NC code or SD code. Just so it's maybe a little clearer. So basically in these sets, we're storing the enumeration values, the num values, and now I want to get out the SGR code, because what I want to do is basically print it out to our we have a BT TTY stream, so that was on startup, we work out where's our TTY. So that's the thing that will print out to the gutter region too, and it's also what we can use to basically do these codes ourselves. But we also kind of have an understanding of what the codes are, so we can print them to a log or display on screen or something. And that way you can test that your application is doing what I do. So I'm kind of trying to build this out to be a nice little test frame harness type thing, but it'll kind of evolve as it goes. So what do I want to print here? I kind of want to print 033, that one, and a square bracket. Basically start us off into CSI mode. And then in each thing here, I want to print here TTY. Now I don't really want to. Now we can do this. This I want to be if actually. Is that kind of what I want? Yeah, I think this is roughly what I want. Yeah, so it would always be testing this. It's kind of like a slow way to do it though. No. I was right. I haven't written out what I am switching on yet. But if I kind of switch on the element, I'm gonna just call it the element at the moment, and this is kind of where I want to have the is kind of list here, and we can probably do something like that. Do you need that after? I think we don't. And then here we can go there, take me there, take me there, and I want to do and X B and L, and Component might complain at me actually. But yeah, so what I want to do here is like kind of convert this to integer and give str code as that integer. Now, what I kind of want to do is do this at the start, and then yeah, and then I want to do something like this, set for each. So in this set, so we want to see the cell attribute set, I guess. And so for each element in this, we want to do this switch statement. That makes sense. Hopefully it does. And so we no, I might actually break this out. So we can do some crazy stuff like this. And we do that. So it's just going to run everything in here. And so at this point here, we can do if idx equals well, actually, if idx, we can do an fprintf. Can actually do an f put c, and we can just put a separator character. We have to give that to the TTY that we're printing this all out to, and then we do that switch thing, and then so perhaps I'll bring this into that kind of point there, just to make it a bit clearer, maybe. And then at the end here, we kind of just want to perhaps I want to do this up here and then like all this just down one more there, and maybe fix up this, and then here we can just do an flush. We need to flush this down, and we can just flush RTCY. Perhaps I do want this kind of. There goes that black sheet again. Skinny muted colors. Cool, and I think that's kind of roughly what I want to do. And then I think this will kind of just magically have color. It will complain about that. That's all right, we can fix things. We're not allowed to do that within that, so it has to be outside of the set for each. That's all right. We are redefining C. We can undef C, and at this point here, I guess we need to. Well, it might not need to be redefined again, but if I kind of want to do that here, and then this it doesn't want. Are we not outside? I would have thought. Oh no, we are still inside. We need to close off the set French, I think. And the semicolon because we have to. Right, so here we have a thing. And it came from here and it came from here. So what is it trying to say? We've got a label at the end of compound statement that basically means that I kind of want to see what it's outputting. So what we can do is, yeah, I was doing some experiments. So I wanted to see whether you could do a kind of range of numbers and to kind of see how you might do that sort of thing. And this is roughly what you have to do this sort of thing. And it's also, you have limitations of this can't be like a 2 times 5 to make 10. It's also got to be the number of things you want to limit, not the upper end. So you can't go upper one a little slower. You actually have to know the size. So like if I GCC that one, so it now no longer compiles because you can't have that times because it's like appending that to a thing. Just can't be done. Anyhow, what I want to do is C minus E, that sort of thing, but I actually want to set C. And perhaps I less that. And what sort of line are we at? 610. So can I go 610 and will it take me to a place that looks familiar? So this is, wonder if we can do that a little. This is this if EQ, so if we scroll down, this if EQ and then fprintf and we do that. But it's expanded out a lot, and it's not like the nicest expansion because it's all on one line, but that's just how it is. So we do this do while loop, and it kind of ends with a bunch of while falses. That's just how it goes. Inside it, we have a for loop, and we have IDX. This cell attributes, which we have, and then size do that, and then we get type of. So it didn't work that out for me. So I guess that's the next stage of the compiler that does that. But the type of the first element is going to be the right thing, and then it gets a copy of that. A copy, yeah, all right. And then we do another loop, and then in here we just have an extra thing. So that's actually this code here, and then in here we have, if we have a positive number, then, well, if we have a number that's not zero, then we put that character, easy. Otherwise we do a switch statement, and then the switch statement, yeah, so we're just doing this that's unfortunate. So what's happened is we go up here and search for it. These come in a particular order. It comes C, then X, then L. So what I kind of oh, it's so gross. I thought I was doing this in a smart way so I could get it back out both ways. I think I need to take the list and kind of build up a static thing. Or what I can do is kind of yank that and paste that there and like call it output or something, or O, and they'll complain in a few places, but here we can kind of do that, and we can kind of curb the yeah, it feels really fine. Yeah, it was just already defined to that from all the way up there. All right. It's good to know. So perhaps I can kind of just kind of keep that, and we don't really care about that, but we do care about O there, and L we can potentially also not care about, just based on the like what it was last defined as. So we're not really changing it. And in fact, like, we could potentially look at what X was last defined as. Now, we did kind of clear that. I will see what this kind of does at the moment. Right, so now it's going to complain in all of these spots. So I think at this spot, we can kind of just define O up in this kind of block of we're defining all of this to do nothing. And now it's cool, that's fine. Def O, and we can redefine O again just here, and we can just have it do nothing. Clear it all up. Right, so here, like, I mean, if it's going to make me do this, expected, STR elements, and we can give it a string, I think, and we can call it a VT attribute string. Yeah, that thing, and we can probably just give it that element and do that. And I think we need to add one more of them. Cool. All right, so what's this? Make thought through. You can just add a break. It's kind of a weird way of doing it, but now, whoa, look, we have color. And you'll see that it's done some things, but it roughly, it's done a few more things now. So maybe if we exit that and run it again, that's what it looks like just out the back. And you can see here that there was some green here. It was meant to have a main, but for some reason it has done things wrong. It's just how it is. So how can we test this a bit nicer? What we have is this run thing. What I can do is kind of change this, and we can kind of ignore the can I do something like that, and it still does kind of what I want. I think that is something Bash is like able to do. So if I just run this, it still runs Bash. It still outputs to the same file. Easy. So what I can do is just comment off those arguments, and instead we can do stuff like printf, and we can even pass in something like this, and I don't know, 41m hello, and then like perhaps we can what should I have a bracket 40, maybe just one m, and we can make the world null, and then maybe we can reset everything. I'll have my numbers again. And we can just do something like that, and then do a few exclamation marks, and we can just printf that, and that's actually a binary on your system. So if I go which printf, you can see it's a thing. If I go type printf, you can see it's also a shell built-in. So if I run printf, it will run the built-in, but if I want to run the command, I can prefix it like that, go command printf, which does that, and I do that, and does that. The usage is the same, but my point is this should print me a thing. So can I have that also, like maybe do let's like just so we can kind of see what it looks like. So it doesn't look right? No color. Should be some color. And what I can do is if we can do stuff like this actually. And then we can do stuff like this, and then it'll just run back. Keep on running on that, but I kind of. So now you can see that is what I kind of expected. So red background, but this one goes bold, and then that kind of resets for the exclamation mark. So that's kind of what I expected to come through, because that's kind of what it looks like. But it's kind of not how it was. So what I might do is maybe do this again and kind of see what what this all kind of said. I mean, if that's just this, I might just have a look-see at this. So from when it truncated to there, this is kind of what I want to look at. So we can see we get the 41M, then we get the hello, then we get another escape sequence, then 1M, cool, and then we get the space, then world. Cool. Then we get another escape sequence, and it's no arguments, and then we get 21, which is exclamation mark. Cool. So we go into escape, we go into CSI, we go into CSI param and 4. Then we get this, and we that did a few more inputs in CSI param. I kind of don't show them all, but here we can see it picks the SGR function, and the arguments are 41, so just one argument. Cool. And here, cool. Yeah, I might actually implement a few things. So if we run this again, will it take me? Yeah, cool. So it does take me here. I kind of need to go here, and if I'm going to be playing out with the backgrounds as well, I should probably do that sort of thing. In here we can probably do something like this, and do that, and then replace that with that, and then also in this section replace 4 with that, and just do that, and then we should be able to case mode. That means that we and then here we need to and then that one, and then find the next 3, and then do the same. Cool. So that did that. So this might be a bit more interesting to read now from the bottom. So we get the same input that looks about right. We get SGR args4, and then it allocates some space for the set, adds in background 1 to the set. So the background 1 I could change to be background red in this case, but it is what it is. I think print out what it is later. And then we go to ground because we've got the Terminator character. We allocate a bit more space, so I'll try and tidy up some of the allocations and not do it as much. But yeah, that is all good. Then we get another SDR. So we would have had some prints in there. I don't print all the prints. But all of these hellos should have done a print operation. And then here we in param, and it would be good to say which cell we're in, so we can kind of see a bit more of the state. Like perhaps I could unify the output a bit more, just to so I can output the state off the state, if that kind of makes sense. And you can just say that it is a transition in your log, and it might come at the end or whatevs. Cool. So then we get this. So now we have a set with background 1 and a set with bold. So we have 2 things in there. And here, yeah, I feel I could show the L there rather than that one. That's all good. Do a bunch of allocations, so I'll try not allocate as much space. But here we go back, and we args nothing, and we still have 2 things in our set. I would have expected to have no things in the set at this point, so might have to find the relevant place there. And then we create a bit of space, then we're just waiting for more input, and then here this is freeing stuff. Cool. So I think I might here we can in here, down there. We can maybe close that one. And one of these ones, like here, why do I still have a lot of stuff in my set of current attributes? Because in here, I thought I was testing if type. No, so I don't want to do that. I want if param, I think. Though, I mean, param 0 does go to none, which is that. Perhaps I want to be a bit more explicit and say that it is that. In fact, I should have done that. So perhaps I want to say if type equals that, except I deleted it. But we can get that back and do that. So if it's not equal to none, which I think is what it was, if tip, then we're appending it. Otherwise, we're clearing the current attributes, which should be doing an array clear, which should be doing just setting the size to 0. Easy. The capacity doesn't change. And so when I do the for each, which is really this for each, I'm using the size. All right, so that's kind of important. I'll see if this change made any difference. So we can see all the leaks. This unimplemented will fix all the leaks, but what I want to do is, so it's still seeing that. So I think at this point we don't have a parameter. So I think I want think I want something like that. So it'll do the loop at least once. And the way VT param works is if it doesn't have a parameter with it, it takes in a default. So it would then use the default of that. If it's not set, it does the right thing. I say, hopefully. Cool. So that did a thing. I don't know if it did the right thing. So might do a sleep and just see kind of what it looks like. Doesn't look right. We can get rid of that, and we're still sleeping. Still sleeping. Cool. So did that make any change to this when we had this? We had args, and we don't actually see what we printed. I kind of want to see this if so like if bt current size, so if size equal to 0, then I just kind of want to say here no, and that would imply that we did a clear as the last one. You can do a clear and then keep on going up 16 parameters apparently. Cool. So at this point here, we should now see wherever it is, no attributes, and then now we just need to see why it is not doing it on I can't was a little dark on that. I could just do this, and we can't do it in the block. Cool. So in the redraw, well, just draw window. Yeah, that thing there. In this, why do we not get to this point here? We're not actually saying what we are, so maybe we can do it here. Sending code, and in here I can just state code. And hopefully then, so we're not allowed a thing. We broke a thing here because we definitely need that one. Good to know. Cool. So that's just those allocations. So I would expect here we have this. So at this point here, I kind of want to see what its output to the screen, if that's like possible to see. Think that would kind of work. And like perhaps we can do something like that and just see what it's up to. And then this is all we send. We all we sent was that go to. So it was actually showing that at the top of the thing. So why do we not in this? Why? Was this sending it for everything? Um, do something like that, and then that again, and then here we can do something like that. We can probably do the same in this case. And then that's doing the case, and we can probably not that far. Do something like that, and then that should hopefully print us out a bunch of stuff. I quite want to clean up the stuff properly, but yeah, cool. So when we see code, so this is interesting. On 632, all the way down here, it hasn't sent the whole code, so I need to finish this off. So that is my downfall of this. So we just need to send not a W, EM, do something like that, and perhaps these perhaps these sequences can be macros, like CSI, start and whatnot. Cool. So now I kind of want to see if it did the thing. So we can just kind of see that. And it looks like it's done the thing. So as the next test, what I'll do is kind of go back to what it was. And I think I can just run this again. And I'll just magically go into that. And I have a color prompt. And that is roughly what it should look like. It kind of looks a little funny, like with this. Like that seems it's cut off. Like that's gone bold, but yeah, it's come away. Look at that. And like, I don't know, I could probably do something like VTOP. Oh, I can't do that, but can I do that? No, because I've got a so in this real, kind of want it's kind of trickier to do it in macros, but we can do something like that. Kind of don't want to know about it at the moment, but I do want to know about it in some time. But I think if we run BTOP now, it might work. No, we don't know. An F. Cool. So I think I'll get rid of this, get rid of that. We can find the F and then do that, and then do something like that. We don't need that one, and we don't need that or that. So now if we go here, we can see that. So that just fresh. This is the only unimplemented. I exit and then I get an unimplemented in free. We need to do this. I'll get to that because I don't know. I'll get to it. At the moment, we're like just pouring memory out. We're just, who cares about it? Who cares? Like, who wants memory? Who wants memory? But yeah, so something like this. We don't have a case for 1049, it does that for a private question mark function. So we can look up, I think I had, this might know the case. So we can have a square bracket question mark. And what was the code? It was 1049. I think I know this. Yeah, so it's enable alternate screen buffer with cursor save and restore, which I have in one of these as well. So there's like, I've got cursor save. And was this 1049? Yeah, so 1049, they say cursor save restore, but this is like with cursor save and clear on exit. On reset, cursor is restored after switching to the primary screen as if restore cursor was invoked. I think the way I do it, I just always save the cursor because I have two separate cursors. I think I don't need. But like, does that kind of mean that you could? I mean, I suppose to be specific to it, what we can do is see in this list. We have alt buff, so I actually have one. What we can do is 1049, and get rid of that, and we can get this and. Put me in the right place actually. There, and we can call this save restore. Save clear. Save clear. Let's. We want to go that far. We can go there. We can go there. Ultimate screen buffer with save cursor and clear on exit, and restore there on exit. It's really both of those cases. On restore, it's restored after switching to the primary screen. Clear on enter. This is clear on enter, but this does not mention anything about clearing on enter. And we can see kind of what my terminal wants to do with it. So if we go over 3, then it was a question mark 1049, was it? We can just enable it. This is where we are. So it kind of cleared it. I kind of want to go maybe go back. So it kind of was in a state, and what we can do is we can sleep for maybe 5 seconds, and then we can see where it is. So it's kind of in a cleared state. The cursor is like down the bottom. So the cursor is on the line that this one, it didn't clear on entry. No, we need to get out of it. Yeah, so perhaps this should, if I wait the length of time, we will lower it. So I think it's just on the line that you are on. So like after pushing enter, the cursor would have dropped down to this line. So if I go down there, I believe it will be on this line, so the next line after, and it is roughly exactly in that place. And for some reason, when it's down the bottom, no, it would have just been in the right place before. Maybe it was just when I do that. Now that seems fine as well. So if we go out there, so yes, it clears, and I think mine will just kind of magically do this. Clear on entry, save cursor. Wow, save cursor. And clear on entry, and clear on entry, and restore. And like, is it clearing on the way back? What we can do is do this thing. We can do a printf high as well, so it has some content there. That high, does it disappear? It kind of does, because just the buffer is gone, so we don't really care about that. Restore on exit, restore cursor on exit. Bit of a mouthful, but we can call it that, because that is roughly all the functions that it is doing, because they decided, let's overload this function. So what we can do is, I kind of almost want to make it a thing. So this VT alternate buffer, it doesn't save the cursor, but the way it's set up is it just copies whatever the primary buffer is, and the saved cursor is on the primary buffer. But the cursor also is just on the primary buffer. We have 2 sets of cursors, so I think this will roughly do the same thing as like, I feel it will clear on exit as well. So what I could do is like, perhaps we can do something like this, and like roast, but we can do something like bash -c of all of that. It's a little gross, but then I don't know, we can also after this one do a print printf by, just so it's printing like that. So we go into it. Maybe we'll have some content before we go in. So printf before, you'll see if we clear it. So we'll sleep 5 there. Then we'll go into the mode, which should save the cursor, clear it, and then we'll go higher, which should make more stuff, and then we'll sleep for a bit so we can see that. Then we'll leave it, then we'll print by, and I think we also want to sleep 5 there so we can kind of see the output. And I think we need to output 2 to somewhere. And so this should not do anything. Cool. If I run it again, it's not working because I've just implemented a thing, and we've kind of got this thing which doesn't really make much sense with the way I'm doing it, but I don't know, maybe it's useful to know. So if I go back into there, that kind of works. Cool. If I do this now, we can see what it does. I can't do that. I think it's because we need to do that and not care about that, and like let's do that one, or can we do that one instead? Yeah, and then just that, I think. So before then we clear it, we clear it, we don't clear it, we clear it, we print high, and it seems like the cursor just picked up where it was, and we go back and we still see higher. I would have expected to see the high again, and we definitely go out. I wonder what this is kind of saying. So our input alt buff save clear, and we're enabling it. Quite a mouthful. It kind of spills out just all over the show. Interestingly, there's like a new line there. And then we got some more stuff because like there was a break, and so this is another disabling alt buff in there, and was that complaining on 985. So 985, and we can go to there. And so, right, so this was complaining in the clearing of things. So I do something like that, but we can do here but to me, so I only really show up in this like case. Kind of I don't know what I want. I think I do want this, and maybe to give it fix me, because it will change, because I think I want to do things a particular way. So I wonder what this looks like now if we kind of run that before sleep for a bit. We get some input, we get high, and then we sleep for a bit, and then we should get some input, and then we get the before and by, and the cursor went back to where it was before. That's pretty good. We've got memory leaks, but that's what it is. And now it doesn't know about 1002, so we can just go like 102. And this is button event mouse. I might leave that. Because mouse reporting, I think I've if we do a search, we have mouse reporting. I mean, I can kind of just do it again in 102, 1002. Don't always need shift down. So what did I reckon it was? Enable mouse button reporting. So we have like mouse and 102 will be like one of these. Buttons. Is it this one? It doesn't really say. That's just 9. So that 9 is 102 is what we're after. This is what we're after. Mouse click and drag tracking. So that's click only, and that's click and drag tracking. And this is button event mouse report. And this one doesn't really give that much information, but button click and dragging tracking. So there's a way we can do that. I think not for now, but we can see mouse for details. So this kind of set it, click and drag, send mouse button, press and release, mouse movements while a button is pressed. So like how we will have to deal with that is we'll have to turn on this mode to our TTY and then listen to the keys, and then we'll have a key that will kind of get shown. So this has like a emit key. We have keys that kind of get emitted, and like these mouse events will just be a mouse key, and you'll just call it a key because in reality that's what it is. So mouse. So this isn't VT. This is that. I mean, is it VT? But I mean, we were putting it for 1,000, and 1,000 was this one, and that's just what this thing said. Hard to know what to call it. Like I would be down for these kind of formats. So like that's press release, and that's like press release and mouse events while a button is pressed. So like a drag, yeah. And which one were we adding? 102. There was so click and drag. I reckon I'm going to call this click and drag. And drag, making it the new biggest. With click and drag. We do that. What's the malfunction? Do that. Cool. Thanks. Finally gets there and then do that sort of thing. And then this we can be the way. and call this private question. We do need that question, that one. And this I am going to call mouse, and so just 1,000 was click. I'm just going to call that click. Well, that's click only. So I think press release. So press possible shift release, and then we can go back there and do the same thing there, and then here's mouse reporting with press and release. Press, drag, and press release, drag, release, and drag, and do I want the opposite color. So then we can change, or not that much, press release and drag. Now all these kind of get pumped out a bunch, because that is what it is about. It kind of makes me want to so also find that and press release and drag, that sort of thing. Cool. So now we basically got unimplemented things. We just implemented the thing that is unimplemented. So I mean that counts as kind of weird. But now if I do that, it's just going to hit that case. I guess I could turn it off with. I wonder if I'm just trying to run something colorful. I mean, like color test. Yeah, I've got a color test, and so I mean, I can kind of do that. Can't do all of them. We don't have this, so that means yeah. So like, I don't know. Currently, at the moment, it's going to look like this. Size T. In fact, what I might do is VT. No, it's kind of like this. For size TI equals, and it really depends on which case we're doing. So if it's this, we're erasing in line. So we only really care about in like 0, this kind of EO erase in line. So from the cursor to the end of the line. So we want to check all the things from the cursor to the end of the line. So we want to get the cursor dot y, and I is, so I kind of want to subtract the 1 off now, and then we're going to have this is just buffer width, and so we're just going to get those upper ones, and in here we're going to if buffer cells, and here we're going to have buff. Well, we've got the I, which is the take that back. And then we just have the buffer.x, and then we have to subtract one off that one. So if this thing here has attributes, I think it's called that. And so this attributes is just an attribute set. So what we can do is, instead of doing if, we can go set clear. And I guess that set clear can do some copy and write stuff when we do it. So that's what we want to do there. And that's a for loop, so we'll just kind of close that off there. In this case, the one is from the start to the cursor. No, yeah, from the start to the cursor, and two is the entire thing. So the start is going to be 0, and then this is going to be cursor dot. And this is line. So and then here this x really needs to be, well, that means it's this is that, and then this is going to be buffer y minus 1 times that. Yeah, that looks good. Cool. And so in this case, it's going to be, we're going to start at 0, and we're going to be less than that, and we can still go up, and it'll be the same equation. Then this one will just be less than that go there, and then this will be the width, and it can go all the way up, and then that can be that. Cool. So that's how we do it for that arrays in line. We also have erase, and we have arrays in page. We have a similar thing here. So this is going to be this is interesting. So we want to have a y, which is just going to go through where we are currently. So this one we're doing arrays and display. So from the cursor to the end of the screen. So we kind of want to start at where we are. And so this is going to be height, and that. So now we want to kind of do a bit of a set. So here we kind of want to change these to be x, if you know what I mean. Just to make it a bit clearer, and then these ones can also be x up. And then here we can that one, and yeah, around it, and that can just be, and we can do the subtraction there. Now, so here, if y is equal to buffer y minus 1, so if that whole thing is the case, then we want this buffer x minus 1. Otherwise, we want to start at 0. That makes sense. And I think the compiler should be happy with that. And so now if I copy this by the line, and we can do this. So this is, we're wanting to go up to this point here. So what we can do is just go all the way equals that, and then y is less than that, and do something like that, same sort of thing. And now if it is equal. So now we kind of want to go here, and it's this case. We want to x is less than. So if this is the case, then we want that x to be less than just width. Otherwise, oh no, we want it to be that one. Otherwise, we want it to be buffer width, width, like so, and then be that. And if it is the whole thing, we just want to kind of go through everything. So there'll be types there. And then we'll just do that set clear. And I think that is what we want up in 3. So in this thing here, we just want to do something like that. And I think I might just do that, and then here we can replace buffer that with VT primary buffer dot, and we can do that everywhere. And then down here we can go into a mode here, and this can be alternative. We've got that, and then we want to clear for that, and then that can be that one. And that's probably all the tuners at the moment. So that just didn't have that, but that means we kind of want to do that, and we can play next. We want to do that, and then we can do that one, and then we'll probably complain in the places. That's a few places for it to be wrong, but no, that seems right. So we just want it on there, so that's probably that. This we want to be there. Can we search for the Y, and we can just do some like no, that, and then cursor dot Y. Now we kind of want, no, I don't really want that. I just want cursor dot there, and then we can do that, and then we find the X because it's also there. And here we can just do that sort of thing. So I thought, yeah, and then do the same thing there. And here is where I thought it was kind of complain about things. That's all it needs to complain about. Cool. So I don't know what we're running page top. I mean, it put out some colors. So now it's got like, I don't know, escape functions and whatnot. But I think this is kind of cool. So what I've got is a set that it's terrible memory. So I think the next time, because it's getting a little chilly and I've just got this, gonna walk back to the house. This is a good point to leave it. So we've kind of got color going. The boldness is kind of strange there. I'm not too sure what that is an artifact of. That's because we resized, and the resize is kind of interesting. So yeah, next steps, we got some more stuff that we could do, more functions we could do. I'm kind of keen to start writing a log output so we can get a clear capture of each frame as it's kind of processed. So that's potentially going to be something in draw frame, that every time we draw a frame and we have a dirty frame, we just print out what we head to the relevant place. And part of that is I also kind of want to get timing information so we can see when we get input, so then we can replay that same input at the same time, which is a very useful thing for testing. We can say it is meant to look like this, and this is what's meant to happen when you push up, and then wait for this, and then that 5 seconds later, this is meant to happen, all sorts of things. And like, you can start to kind of build it out and start writing, hey, I want a virtual terminal this size, can you write this to it? These are the streams that come in. What's it look like? Does it look like the thing that I want to do? And part of that is making sure this program works well. And one thing that's kind of cool about this program, it can run itself. I mean, if we do output it, we'll get some errors on some, but we are kind of writing inside, and it's interesting that we have a discrepancy here. It means that something in it is not right, because theoretically we should be able to do something like that and run it 3 times, and now we get like a whole lot of stuff. But I think that crashed, but I don't know why. It'll say why buffer out of bounds. Interesting. So there might be some bugs to fix in that, but I don't know. I'm quite happy with this. And it would also be kind of cool for this this display to have a kind of heads-up display, maybe down the bottom or like down the side, showing what the keys are that you're pushing in real time, so you can kind of see a mouse happen at this point, and then maybe if I show some timing information, I don't know. Yeah, it could be kind of cool, but I don't know. Hopefully this is of interest to other folk. And yeah, please do let me know if you are enjoying this. Otherwise, what we'll do is just run the right command and maybe just add up all the stuff that we've done in this stream. Some of it was me fixing that macro bug. So now we kind of have that, and we still have it unimplemented. So in this, we probably want to get that inside. Maybe take me back to here. Yeah, so I kind of want to grab this and put that there, and also there, but like only if original. And if can we go that way? If original, we kind of want to do that. And what is original looking like? Original is just the cells. I kind of want to have the original buffer. No, I do want this. So the cells is what I want, but the region is different, so we save it to original size there, so we can go and this is original size, and then we want the number of rows, and then here we do that, and and do something like that. And so now we already have the cells saved, but then the width is going to be original size. Sometimes typing just gets way too hard in the afternoon. Cool. So right, so we'll have that, and we can probably chuck in a free original at the end. And this cells is going to be original now. Then we don't need to do that. And I kind of want to make sure that's right. That's kind of weird that that's not. That looked good. That kind of seems alright. So in this case, I think this is roughly what I want to do, but without the free, because well, is it? Um, I think I want to kind of make a note, fix the take note of the attributes when resizing, because I think with that change there, if I go like this, we get a color. If I resize that, we still get a color. Cool. I thought we would have lost the color in that process. We still have a thing here. Cool. This I just need to find all the places. Actually, now can we go back to that one? And take me back to here. So if we're scrolling up, we want to that we kind of want to be more like the arrays in line. So if we're scrolling up, we kind of just want to. Wow. We're losing the first row, so we kind of just want x to be 0, and the cells, this is just going to be whatever is in the first row. Looks a little weird, we don't have the y, but I believe that is what we want if we're scrolling up, because we're losing the last row. No, we're losing the last row. So here we want to do buffer height -1, and that's not divided by anything. That is times by buffer width, and then we're going to plus on the x that we have, and let's go to here and make sure that is cleared up. Cool. So that's that. And then if we're scrolling down, we want to just find that, and then maybe like do that, and then do that easy. And if we're scrolling left and right, we will need to do some things. So maybe I'll just paste that there and paste that there. I mean, I can do a loop that will do it. In fact, like this kind of loop would roughly do it. So perhaps I'll do that. So if we're scrolling left, scrolling left, then we're losing the leftmost thing. So that's going to be when x is 0. So we're pretty much going to be looping over y. And if we do something like that, and then this is going to be over height. And then here we're going to have y times buffer width, and then that should show just the first column. And then here we can still want to go from top to bottom, but then here we want to add on one. What I could do, because it's going to be, in fact, yeah, I think I will, because we're going to have to do that. So we're going to have to do a subtraction anyway. So what it is going to be is that. So basically we're adding 1 to the y, we're getting 1 extra, and then we're subtracting 1 off, which should get us to the end of the row. So the last element. And so that is that. So we can clear out all these. So clear all. So here we kind of have that. We set that up in free, I guess. So in free, and we do it indeed for the ultimate set. So we can kind of just yank that over here. And perhaps yank that into the right place. And do I that was the last one. Cool. So now what I might do is make sure it still runs and still has pretty colors. Cool. And it does sometimes, but that's all right. And now what we can do is kind of add things in. So we can do that. We did some refactoring there, so the gutters kind of get drawn in a different place. Then we can do this kind of stuff. That's just reprinting out the code. Here we doing a bunch of free and whatnot, so just do free, just clearing the set where it needs to get cleared. I just realized that set clear doesn't actually do anything. Well, it doesn't actually do what which I think I have noted because I've been running and I'm still getting leaks, and so I've not actually. What I want to do is have a set free, I guess, and so what this can be is we can do some stuff. Perhaps we can clear an array, and then we can just go if capacity equals, actually no, we'll do something like that, do something like that, and capacity equals 0, and we also want to do a free of S, the data, I believe that is where it is, and that can be protected by while false. And what I kind of want to do is make this array free, free, and we can just define set free of S to be array free of S, and that can be that. I'll do that awesome. And then here we can S. That's kind of all right, but maybe if we do that, that'd be better. And we can replace this with A because it's now array free, and we can kind of pull this up. I don't know, like just bonk it there. And so now when we do the set clear, wherever we do this, we probably want to set free. So we can just kind of go through when we're scrolling. This is we're writing stuff, we're writing stuff, we're writing stuff. Here we're resizing it, and that's probably why. Well, no, because it would have disappeared. But I think here I want the same. Here we're closing the alternative buffer, so I want to free it. Here we're erasing in line. I think I want to free it. Like I think I just want to do the set thing everywhere except here, because this one is basically clearing the set but keeping the memory that was allocated. And I think, yeah, cool. So now that's the only two sets. And now I think if I run this, and that doesn't work, cool. That's meant to be that, and this is just meant to be there, and something like that. And so now we run it, we get colors, we close it, we get a leak still. One leak. I reckon I can fix a leak. So this is 12,064. That's not number 1264, and then we can go here. So this is happening in here when we set clear. The current attributes is in the VT, so in wherever we do the free, we need to do a set free of VT current attributes, one of those, and then this should get no leaks. No leaks. I like no leaks. Cool. So here, if we kind of go here, maybe we can restart this process. We are good. Right, that was kind of weird. So we got array free now, and now we do the set free in places that we wanted to do. So the diff's a bit small here, and I think I'll put in this little comment about the copy and write, commit to it, because I'm kind of interested in doing it. I think I've got ideas on how it will work, and it potentially will run into other projects I have interest in. Yeah, we got that buffer out of bounds. I might play around with that and see whether I can hit that again. Here we make sure that we go through at least once with that p equals 0 or p is less than the number of parameters. We won't do 0 twice. We'll just do 0 even if there is no 0. Don't print it out, that's right, but we'll leave the code there. It can be useful to kind of see what's happening. That's like kind of depending on set, that's kind of printing it out. We implemented some things. Cool. I think that's good for a thing. It added color pretty much. I think it's. I mean, I've done a few other things, but it pretty much made the color working. So I think that will be that. And thank you very much. I know I said it was the end before, but you got to stay on for some extra leak fixing. But yeah, thanks for that. Thank you for watching, I mean. And I will see you next time with hopefully more stuff. Maybe some copy on write, maybe some mouse stuff. I don't know. There's a few different options. Other than logging as well, replaying. There's a few things I want to do. But hope you enjoy and have a good evening, day, wherever you are, and I'll see you next time.